This is the sixth lecture of the series of linear differential equation constant coefficients. So we find here various types of particular integrals. In the linear differential equation, the right hand side x is equal to e raised to x. Then what is the particular integral? When x is equal to sin x or cos x, then what is the particular integral? Then, so now we take here the type when x is equal to x raised to m, then what is the particular integral? So particular integral when x is equal to x raised to m. Okay, then what is the particular integral? Okay, so let we consider here the linear differential equation with constant coefficient is equal to capital X, where x is x raised to m here. Then when x is equal to x raised to m, then what is the particular integral? Pi is equal to 1 upon f of d. F of d is this, and this is x is equal to something. What is f of d? So this is f of d. This is f of d. Okay. So we write this f of d in this form 1 plus pi d. We write f of d in the form 1 plus pi d. So we take out 1 and remaining is pi of d. So we write here f of d is equal to 1 plus pi d. So putting this f of d is equal to this and x is equal to x raised to m, then 1 plus pi of d, just made 1 upon 1 plus pi of d. What is x? X is equal to x raised to m. So this is 1 plus pi of d raised to minus 1 into x raised to m. Taking this factor to numerator, that is x raised to minus 1 into x raised to m. So this is a particular integral when x is equal to x raised to m. But we know the formula here. So just what are the formulas here? So what is the 1 plus x expansion of 1 plus x raised to minus 1 is equal to what here? So 1 plus x is 1 minus x plus x square minus x cube and so on. Similarly, 1 minus x raised to minus 1 is equal to 1 plus x square plus x cube and so on. Okay. So this is the particular integral when x is equal to x raised to m, then particular integral is this. Okay. So we use this formula in the example here. So we take example. So we take example. So solve dq plus 8 dq plus 8 y is equal to x raised to pi u plus x square plus 1. So solve this example here. Okay. So what is the solution? The auxiliary equation is what? The auxiliary equation is dq plus 8 is equal to 0. So this equation can be written as d plus 2 into bracket d square minus 2d plus 4 is equal 0. Multiplication of this is dq plus 8. This is very simple. You simplify this. Okay. So then d plus 2 is equal to 0 and d square minus 2d plus 4 is equal to 0. So that is d is equal to minus 2. That is the first root. Find the roots of this quadratic equation. Then what happened here? So that is d is equal to minus b. B is what? Minus 2. Then minus b is plus 2. Plus or minus square root of b square. What is b? B is minus 2. It's square. So that is 4. Minus 4ac. 4 is this. A is 1. 4ac, that is 16. 4 into 4. This is c. Divided by 2. Okay. So this equal to 2 plus or minus. So this is the root minus 12. 2. So 2 plus or minus. So what is the 12? So this is 3 into 4. 2 taking out from root. So this is minus root 3 divided by 2. So 2 to get cancelled here. So then what happened? 2 to get cancelled. So 1 plus or minus. So what is minus root 3? So that is root of minus 1 is I into root 3. So I root 3. Therefore the roots are, so that is minus 2. 1, these are the imaginary roots. 1 plus I root 3. 1 minus I root 3. 1 real and 2 imaginary roots are here. So therefore complementary function is CF is equal to okay. So C1 e raised to minus 2x. Okay. So C1 e raised to m1x. So m1. So this is m1, m2, m3. Okay. So this is equation. This root is of the form alpha plus I beta, and this is alpha minus I beta. So this is m1, m2, m3. So c1 e raised to m1x. So m1 is minus 2 plus what happened? Then so this is alpha is what here? 1. Beta is root 3. Then what is the formula to find the CF when the roots are imaginary? So therefore e raised to alpha x. Alpha is what? 1. So e raised to x into bracket C2 cos of. So this is standard formula. We're taking many examples by using this. Okay. Cos beta x. Beta is root 3. Beta is root 3. Alpha is 1. So root 3 x plus C3 sine root 3 x. So okay. So this is the complementary function. So what is the particular integral? Particular integral pi is equal to, okay. The next part, pi. What is pi? Pi is equal to 1 upon just f of d, 1 upon f of dx. Okay. So then what happened here? So that is 1 upon f of d is what? F of d is this. D cube 8 plus d cube. We write this 8 plus d cube. Okay. F of d is this. And what is x? X is in this example x raised to 5 plus x square plus 1. Okay. So this equal to 1 upon. We're taking out 8 from this. So remaining in bracket 1 plus d cube upon 8. D cube upon 8. We'll take 8 common. Okay. So this is x raised to 5 plus x square plus 1 here. Okay. Very simple. Therefore 1 upon 8 into bracket 1 plus d cube upon 8 is equal to x raised to 5u plus x square plus 1. Okay, or raised to minus 1. So that is important. Raised to minus 1. So what is this is, so this is 1 and this is x here. So 1 plus x raised to minus 1. 1 plus x raised to minus 1 is equal to what? So this is 1 upon 8 by using this expansion into bracket. So what is x? X is what? 1 minus x. X is d cube by 8. D cube by 8. And what is this? Next is x square plus x square. X is what? D cube by 8. So that is d raised to 6 divided by 8 square, that is 64, plus and so on. So this is x raised to 5u plus x square plus 1. But these terms are neglected here. So higher degree terms are neglected. Why? For example, so what happened here? So that is d cube something and x square. So what is the d cube x square? So first derivative is what? First derivative is, so that is d cube into, so d into d square x. So that is d, so d square into dx x square. So first derivative what? D into x square is d square into twice x. Then again using one derivative. So what is d into d of 2x? D of 2x, that is d into derivative of 2x is 2. So and derivative of 2 is 0. So here degree of x is 2 and we're taking third order derivative. So this is 0. So degree of x is 5, 2, and we're taking d raised to 6 is the derivative. So then terms from this these terms are taking derivative of 0, taking derivative of this term will get 0 here. So these terms are neglected. Very simple here. Okay. So what happened? So this is 1 upon 8. So this is what? This into 1. So this is x raised to 5u plus x raised to 5u 2 plus 1. Okay. Then apply this on this. So what happened here? So what is the first derivative of this? D cube of 8. D 1 upon 8. Okay, as it is. What is the third derivative of x raised to 5u? So first derivative is what? 5u x raised to 5u x raised to 4. 5u x raised to 4. So first derivative. Then what is second derivative? 20 x cube. And then third derivative d cube of this third derivative is what? 60 x square. So this is 60 x square. And the d cube of this is 0, this is 0, not up. So this is the particular integral by obtaining here by using this formula, here. Okay, so we write this in the form of 1 plus 5d and so on. So this is particular integral. So the complete solution is y is equal to CF plus PR. So we write here CF. CF is this. What is CF? CF is this here. CF is, so this is CF. We write here. And what is the particular integral? So this is the particular integral. Okay. So we get the required solution. So we take another example on the same type. So we solve how to solve this differential equation. Okay. So next example. Very simple examples are there. Okay. So what is the next example? Okay. Example. Solve d cube plus 2d square plus d into y is equal to x square plus x. So solve this differential equation. Okay, what is the solution? The auxiliary equation is what? So that is d square, d cube plus 2d square plus d is equal to 0 here. So d taking out, so d square plus 2d plus 1 is equal to 0 here. So then what happens? So that is d is equal d into, so factors of this d plus 1 is equal to 0. So the roots are, so d is equal to 0, d plus 1 is equal to minus 1, 0, d plus 1 is equal to 0, minus 1. So these are the roots. Here 1 minus 1 is repeated twice. So what is the complementary function? CF is equal to C1 e raised to 0 into x. So that is 1, no doubt. And if the roots are repeated, then e raised to what happen here? Just a minute. C2 plus C3 x. If roots are repeated, then e raised to minus 6. So we find out this CF. So we make practice how to find the complementary function when the roots are repeated, imaginary, when the roots are different. Okay, and we take many examples of such types. So now particular integral. Now pi is equal to 1 upon f of d x. Okay, what is f of d? F of d is what here? F of d is this. Okay, so we take this or this, not 0, this. So that is d into bracket d square plus 2d plus 1 into x is what? X square plus x. Okay, so that that is 1 upon d. So that is 1 upon 1 plus, this can be written as in the form 1 plus pi d. So 1 plus pi of d. Pi of d is what? D square plus 2d into x square plus x. So this is 1 upon d taking out here. So this can be written as 1 as it is, and d square plus pi d. So this is pi d. So this equal to 1 upon d. So this is 1 plus d square plus 2d raised to minus 1 into what happen here? Into, so x square plus x. X square plus x. Okay, so this equal to. So what is this? So 1 upon d. Okay, 1 upon d into bracket. So that is 1 minus, so this is x, this is x, this is x. So 1 minus d square plus 2d. So this is x, x square, d square plus 2d. Okay, bracket square, and the higher power terms are neglected. So into this is as it is here, x square plus x here. So okay, we find here, so this is 1 upon d. 1 upon d is equal to, so what happened after simplification of this? So 1 minus, so what happened here? So that is 2d. Okay, 2d. So minus 2d plus, so this is minus d square. and this is what? 2d square. So minus and plus square 4d square, and this is minus 3d square. So x square plus x. Okay, x square plus x. So that is, and higher power degree terms are neglected. So this equal to, so what happened here? So after, so this is x square plus x. So operate d on this and d square on this. So we get here 1 upon d. So that is x square minus 3x. After simplification, so this is very simple. So there is no time to solve this in detail. Okay, so you simplify this. So this, so what is 1 upon d? So this is again integration. 1 upon d, nothing but integration. So x square minus 3x plus 4. Okay, so dx. Then what is the integration of this? So x square, that is x cube by 3, minus x integration, that is x square by 2 plus 4x. So therefore the complete solution is y is equal to CF plus PI. So what is the CF and what is the PI? So CF is what? CF is this, this, and PI is this. Adding those CF and PI, we get the complete solution here. Okay, so we take another type of to find the particular integral. So next part is what? Next part is x is equal to e raised to x into v. Okay, where v is a function of x. There are two functions. So this is a function of x also, and v is a function of x. Okay, if x is in this form, then what is the particular integral? Then what is the particular integral? When x is equal to e raised to x into v, where v is a function of x, then what happened? Then the particular integral is pi is equal to 1 upon f of d x. So that is equal to 1, that is 1 upon f of d. What is x? X is this, e raised to x into v. So this is equal to e raised to x. E raised to x. Then put d is equal to d. Put d is equal to d plus a. This a, d plus a into v. Into v. Okay. So this is the formula to find particular integral when x is equal to e raised to x into v. So we take example. Solve. So solve. Okay. So what is the example? We take very simple example. Solve d square plus 2 y is equal to e raised to x cos x. Okay, the auxiliary equation is what? So that is d square plus 2 is equal to 0. So d square is equal to minus 2. So I square into 2. So d is equal to I root 2 and minus I root 2. So what is the complementary function? CF is equal to C1 cos root 2x. So these are very simple. So can't discuss in detail this. So that is the 2 sine of. So this is sine of root 2x. So this is a CF. So particular integral. So pi is equal to what? So particular integral is what? 1 upon f of d x. 1 upon f of d x here. So what is 1 upon f of d? 1 upon f of d is what? D square plus 2. So this is what? So this is e raised to x cos x. So this is what? E raised to x is this. V is this. V is this cos x. So this is e raised to x and this is v. So by using this formula, this can be written as e raised to x, e raised to x, then 1 upon d plus a. A is what? A coefficient of x. So that is a is 1. So then what happened? D plus 1. Put d. D is equal to d plus a. Means d is equal to d plus 1 putting here. So d plus 1. Bracket square plus 2 cos x. So I'm simplification this e raised to x. So 1 upon, so d square plus 2d plus 1 and this 2. So then d square plus 2d plus 3. Okay. So cos x. Okay. Cos x. Then what happened here? So again use the 1 upon pi of d square cos x is equal to 1 upon pi of minus a square. Put a d square is equal to minus a square. Then what happens? So this is equal to e raised to x 1 upon what happened here? So d square is minus a is 1 square and then minus 1 plus 2d plus 3 cos x. So this is equal to e raised to x. So what happened here? 1 upon 2 into d plus 1 cos x. Okay? Very simple. So this is e raised to x upon 2. So this can be written as d minus 1 multiplying by d minus 1 to numerator and denominator. So this is d plus 1 d minus 1 cos x. So this is equal to e raised to x upon 2. So that is d minus 1 d square minus 1 cos x. Okay. So this equal to e raised to x divided by 2 d minus 1. So what is this? Put a d square is equal to minus a square. D square is equal to minus a square. So coefficient of x is 1. So this is a is 1. A square. 1 square that is 1. Again minus. So minus 1 cos x. So this is what happened here? E raised to x minus divided by minus 2 into 2 4 here. So that then what happened? So d of cos x minus sin x and minus multiplying by 1. So this is minus cos x. Okay. So this is the particular integral. Then what is the solution of this equation? CF plus PI. CF plus PI. So what is CF? CF is this. PI is this. So we get complete solution of the given differential equations. Okay. So we discuss here the another form. Okay. So when particular integral when x is equal to e raised to x. So again one more formula to find the particular integral like that. Particular integral when x is of the form where x is equal to e raised to x. Another formula e raised to x is equal to v, and let this is the linear differential with constant coefficient. Then x is equal to e raised to x v, where v is a function of x. Then pi is equal to another formula here. So you see this formula and solve examples. F of d x is what? Capital X is something just here is xv only. xv e raised to, instead of e raised to x we write x, and v is the function of x. Then here is x, xv in the last formula there is e raised to x, e raised to x. V is the function of x. Then what is the particular integral here? So xv is equal to, so x into 1 upon f of d v minus f dash d divided by f of d bracket square, f of d bracket square into v. So this is the formula to find particular integral. So in the last particular integral there is e raised to x into v, but here is x into v. Something x is v is a function of x. Then particular integral is of the type here. Okay. So this is the formula. So we stop here. We take example by using example, solving them by using this formula to the next lecture. Okay. Thank you.